great to see so many people after lunch. I'll do my best to fight the lunch dip. Welcome to the session, the Swiss Army knife of cloud native networking. There were already two other talks also discussing Cilium, but I will also discuss some new capabilities of Cilium for you to be interested in. So a bit about myself. My name is Raymond de Jong. I'm Field CTO EMEA at Isovalent. I'm Dutch. I actually live in Switzerland because Isovalent was a partly Swiss company, so I moved there. I love that country, so I'm also known as a volunteer ambassador for Swiss tourism. So if you plan to go to Switzerland, I can give you some great tips. Isovalent is now part of Cisco. We got acquired by Cisco in May this year, but we're still a startup within Cisco, and we are the company behind Cilium, eBPF, and Tetragon. How many of you know about eBPF? Can I see some hands? Quite a lot already, cool. How many of you know Cilium? Good, okay. For the people who don't know eBPF, I will briefly introduce eBPF. eBPF stands for Extended Berkeley Packet Filter. You can forget that acronym already, but what eBPF makes special is that we allow to run programs in kernel without changing the kernel. And we like to say what JavaScript is to the browser, eBPF is to the kernel. It makes the kernel programmable in a dynamic and safe way, and it allows us to do amazing things at kernel speed using for networking and runtime security use cases. So we use eBPF to attach eBPF logic on kernel events. And for the topic of today, we're focusing on networking events. So think about load balancing, forwarding packets. You have heard maybe cluster mesh, that's also eBPF powered. Parts of the service mesh capabilities, we use eBPF to accelerate the data plane and to forward packets. Also, if you use metrics, if you want to observe traffic, using our Hubble solution in Cilium, it uses eBPF to get metrics such as interface, latency, throughput, and so forth. Cilium uses under the hood eBPF to achieve the goals you need, depending on how you configure Cilium. When you install Cilium, Cilium runs as a daemon set and installs on your Kubernetes nodes the eBPF logic to get things done you need doing. Think about Cilium being a car and eBPF being your powerful engine in the car, doing the things to get you there and achieve your goal. So in this session, I will cover a number of features, and I will conclude the session with a demo where I show how we can use these features together and how you get a value out of those features. The features we'll talk about will be Gateway API, LB-IPAM, load balancing, Layer 2 announcement, and BGP. And I will show you how you can use that together to create, for example, a multi-tenant environment with specific IP addresses for specific tenants advertised using load balancers and BGP automatically to the network. So let's dive in. We'll start with BGP control plane. We released Cilium BGP control plane v2 just recently in July timeframe. Cilium 1.16 includes that capability and allows us to meet a number of use cases and challenges. First of all, we want to make the network programmable. We want to make ingress and egress connectivity automated, programmable, provide connectivity to existing networks or clouds using BGP. It also serves a availability use case because if you have multiple nodes as BGP speakers, if a node fails, other nodes can advertise those IPs as well, and the traffic will be automatically rerouted. Also, if you recover nodes, obviously BGP will establish a session and will program the network to receive traffic again. And you can do a lot of traffic engineering. I'm not sure how many people have network engineering background, but BGP is obviously fuels the internet, connects all the countries with the IP addresses across the world. And on-prem, you can obviously engineer traffic for your use cases. Challenges are multi-tenancy, especially if you want to use different IP addresses, you want to send or receive traffic to different sources or destinations using specific routers and such, so that can become complex. Security, obviously, and optimizing traffic, especially at scale. So BGP, as an introduction, is a protocol which is a dynamic protocol. It runs on port 179, and typically a BGP router exchange routing information with another router. So router A can say, hey, I'm router A, I'm part of an autonomous system, and I know these networks. What networks do you know? So the routers exchange routing information, and program the network to forward traffic. Cilium, the Cilium BGP control plane v2, is built to automatically and dynamically configure your nodes as Cilium as BGP routers. We're going to focus on the Cilium BGP cluster config, the Cilium BGP peer config, and the Cilium BGP advertisement CRDs you can use starting in Cilium 1.16 to achieve that. In terms of features, we support both IPv4, IPv6. We allow pod-side IP addresses to advertise services, cluster IPs, and of course, load balancer IPs. We have advanced capabilities such as MD5, password support, graceful restart, multi-hop communities, BFD for super low sub-second recovery and failover of BGP. And we also provide BGP operational tooling. So how does this work? So let me introduce you the CRDs we have introduced in Cilium 1.16. And the first one is the Cilium BGP cluster config CRD. This allows you to specify based on node selectors which nodes should act as a BGP speaker. Then you define one or more BGP instances. For example, you give it a name, you specify autonomous system number, and then you define one or more peers, depending on your topology where you need them. In a peer configuration, you give it a name, you need to specify the autonomous system number for your peer, the peer address, either IPv4 or IPv6, and reference the so-called peer config reference. And that specifies information, and that's the next CRD, about the Cilium BGP peer config. Typically, when you have multiple nodes connecting to a given set of routers on your network, they share the same configuration in terms of secrets, timers, and so forth. So in a peer config, you specify those values. So for example, the timers, the secret you may want to use for MD5 security, graceful restart settings, and address families. And again, you reference another resource, which is actually the next CRD, which will specify what you want to advertise. The final one is the Cilium BGP advertisement CRD. This will allow you to specify what kind of type of advertisements you want to share with BGP, what address types you want to advertise, and also you can use selectors using either specific selectors or expressions to select specific services you want to advertise using BGP. And I will show this in action in the demo. If you're not able to run BGP or you just want to quickly test such configuration, you can also use layer 2 announcements. So layer 2 announcements rely on ARP, right, Address Resolution Protocol on layer 2, and that allows you to have a node respond to requests from the network for example, load balancing services. So let's say you have an external client who wants to connect to a given IP. The network will resolve that IP automatically based on gracious ARP or on ARP and will recover based on gracious ARP when a node fails. And that node will be hosting a virtual IP for receiving north-south traffic. And this is typically great for small environments, test environments and such, so you don't have to configure BGP. So how does this work? There's a separate CRD for that. You will specify services you want to advertise. In this case, I'm matching on labels with color blue. You again select nodes who will be eligible for advertising those IPs. Keep in mind that with layer 2, it's only one node. There can only be one active node advertising that IP and receive traffic for that IP. And then you can define interfaces and specify if you want to do external IPs and or load balancer services and so forth. Let's move on to the next capability, which integrates really nicely with BGP, and that's the LB-IPAM capability. LB-IPAM allows you to define prefixes for different workloads, and you can specify IP pools and use labels to select those IPs from those IP pools for given services. So you can create a load balancer with specific labels, and the Cilium operator will read those labels and automatically assign an IP from a given IP pool to that given service. And this allows you to provide, for example, multi-tenant, multi-traffic engineering IP engineering because you can define different IPs for different sources. I will show this in the demo as well. And finally, what's really cool is that we are also supporting Gateway API. Gateway API is obviously part of Kubernetes. It's basically the Ingress version 2, and it provides a lot of powerful layer 7 capabilities, which we also out of the box support with Cilium. If you don't know Gateway API, it's a set of resources. It's a role-oriented based model where a platform engineer or a cloud operator can define the type of gateway, the gateway class, and then an application owner team or developer team can define HTTP routes and attach those routes to a given gateway. This allows separation of responsibility, control, and separation of owning different sets of resources. Typical use cases are traffic management, layer 7 routing, forwarding specific paths to specific services, also A/B deployments, A/B testing, traffic splitting, canary rollouts, and such. It provides scalability, north-south load balancing. Introducing Gamma, we also do east-west load balancing with Gateway API. And with Cilium, we also have out-of-the-box golden signals, so things like HTTP request codes, return codes, duration, latency, by just enabling metrics in Cilium using Hubble to get those metrics, and for example, using Grafana to get dashboards and available graphs of how well that application is performing in terms of layer 7. We now support Gateway API 1.1 in Cilium 1.16. So we introduced Gamma support, we have gRPC routing, and a ton of other capabilities as well. Also note that we have introduced a Envoy. We use Envoy for all the layer 7 capabilities as a separate dedicated daemon set. Before it was built into the Cilium agent, now we have the separation by default. That allows you to more specifically monitor and operate the Envoy daemon set for in terms of resources and also monitoring how it's performing in general. And it has a lot of security benefits as well. A specific capability I want to focus on with the Gateway API for this session and for the lab I'm going to show is the so-called annotation propagation from the gateway to the load balancer service. If you create a gateway in Cilium under the hood, automatically a load balancer is created. And using this stanza, this spec infrastructure labels color blue, for example, this piece of information will be advertised to the load balancer service automatically. We can use this information with LBIPAM to select an IP from a specific pool, for example. So that's super powerful and capability as well in cloud where you want to have specific load balancing capabilities, for example, with your cloud provider. So it has a lot of flexibility and allows you to engineer what you need for that gateway. I have a lot of time for the demo, so that's good news. So let's hope the demo works. So now we're going to bring this all together and show this in a live environment and see what the result is. So to introduce the demo, I have a few goals. So as a platform engineer, I want to support a multi-tenant, multi-team Kubernetes platform. I want to provide separation and segmentation for each tenant, so I can use network policies per namespace to secure a given tenant and the application for that given tenant. But I also want to use unique IP addresses on the external network for each application for that tenant. Because on the external network, I can decide where the traffic needs to go to and go from, and that allows me to engineer the network as such that we can send them to the right sources or destinations and firewalls and such. I want to provide layer 7 routing and filtering using Gateway API, and I want to advertise the load balancer IPs I create automatically to the external network using BGP. The topology is run on Container Labs environment, so maybe you've heard about it. Container Labs allows you to spin up using Kind, for example, virtual routers. So I use that technology to create routers in my Kind cluster. I use 4 Kind nodes. So I model basically a 2-rack infrastructure. So 2 nodes are in rack 0 and 2 nodes are in rack 1. And I will use specific BGP settings per rack. And then on the Cilium side, I define 3 namespaces, blue, red, and yellow. Each team, each namespace has a dedicated gateway, therefore a dedicated load balancer. And I will show how we use LB-IPAM to get different IPs for each team. All right, let's switch to the demo. I hope that makes sense. If not, let me know. All right. I have already created the namespaces. So if I do kubectl get kubect, I will always use the shorthand get namespace. I see, yeah, the tenant blue, tenant red, and tenant yellow. Right now, the routers are already running, the nodes are running, but if I do, for example, Cilium BGP peer, so that's included in the Cilium CLI, we have no BGP peering yet, and if I do a quick command to basically check the routing tables of the given container lab routers, I can see there is no routes established beyond the default routes they know for kind. So let's see, another example is show neighbors. What we can see here is that the routers that are already configured to peer with the nodes in their rack, but there's not yet a BGP session established, and we can see that here. So it's active, it's trying to establish it, but it's not yet ready on the Cilium side, and that's something we are going to do now. To enable all these capabilities, I'm going to quickly show the Cilium values file. If you install Cilium using Helm, you would use a values file. I've enabled the BGP control plane. I've enabled Gateway API, and that's basically all there is. I'm also enabling kubeproxy replacement to true. That's a requirement of Gateway API, and definitely recommended for each environment because this replaces IP tables on your nodes with eBPF-based load balancing. So next step is let's have a look at the Cilium BGP cluster resource, and this is 4 resources in one file. I'll start with the first Cilium BGP cluster config. Can everyone read this actually in the back? Yeah, awesome. Again, I specify nodes, so these are only applying to nodes in rack 0, 2 nodes. I specified BGP instances to peer with the router in rack 0. I specify a local autonomous system number and the peer autonomous system number. In this case, it's the same. So we're technically talking about iBGP in that sense. We give a peer address and we reference the peer config, which is the set of similar resources across routers. A similar config for rack 1 with different node selectors for the nodes in rack 1, specifying a different ASN for rack 1, peering with a different ASN router in rack 1 with a different IP, and specifying the same peer config. So like I said, this specifies the Cilium BGP peer config resource, which unites resources valid for all routers in Cilium and on the networking side. And in this case, it's a very simple one because I just specify both IPv4 and IPv6 address families, and I'm only will advertise using the labels advertise BGP. And what I'm actually going to advertise is defined in the Cilium BGP advertisement resource. And in this case, I advertise only services of type load balancer. And I'm using this expression to match on color, red, blue, and yellow. So let's deploy this Cilium BGP cluster configuration. Done. And now we should be able to see sessions being established with the virtual container lab routers. So as you can see now, respective routers in the racks have just set up an established BGP session. I can see that here up for 4 seconds. I'm not yet advertising prefixes because that will be the next step, and also the case for the next router. So we've done the BGP sessions. We can confirm that using Cilium commands as well. Cilium will also show we have established sessions with the upstream routers. Next step is to have a look at the IP pools. So I have defined 3 IP pools. First one is blue. I specify a prefix, a CIDR block, and I match on blue services of type load balancer with the label color blue. Let's apply the IP pool blue. No, not red, sorry. I'm using obviously shortcuts, but yeah, done. Okay, let's have a look at the next one. That's the the IP pool red. Similar, different prefix, different CIDR block for blue, load balancers, matching with a different expression, just matching exactly color red. So let's deploy that. IP pool red, done. And finally the yellow, and I want to highlight with yellow something else. You can also specify, for example, a namespace. So in this case, I specify a different CIDR block for yellow surfaces of type load balancer, matching the namespace name, tenant yellow. That can also work. So this defines how, depends on how you want to manage the resources and how you want to have that separation. This is just an example. So apply the IP pool for yellow. There we go, done. So now the operator understands once we create a gateway and therefore a load balancer, what IP it should announce. So let's do that. So let's have a look at a gateway resource. And this is just an example. There we go. Gateway resource, give it a name, gateway blue in tenant blue namespace. I add this spec infrastructure labels and I define the color blue. And then just information about the gateway, listening on port 80, and attaching a simple HTTP route example to that gateway. It's not so important for this demo, but let's apply the gateway blue. So now the gateway is created, and I can do kubectl get gateways in all namespaces. I can see now tenant blue has a gateway configured automatically, and as you can see, Cilium has selected an IP, in this case 120.0.10.0, from the blue IP pool. I can also see that if I do a kubectl describe service for tenant blue, and I'm looking for a specific service which is automatically created by Cilium, I can see these labels are now also attached to the underlying load balancer service. And this allows, again, the operator to select IP from specific IP pools. If I do Cilium BGP peers, there will not change nothing here, only that I can now see I'm actually advertising that single IP to the network. If I do, if I have a look at the router side, what should we show there? We can show the neighbors, we can see we have a prefix being advertised. That's that specific IP. And on the router side, so on the routing table side, I should say, show BGP. I want to show the BGP table. I can see the router knows about these IP addresses and knows where to forward it to. So that shows the interaction of BGP with service of type load balancer with Cilium. Same, let's do the same for a red gateway. So similar idea, just adding the labels. That's the only difference. Let me apply that gateway red. Quick look at the yellow gateway. Yellow gateway, same construct, labels color yellow, but the IP pool selects services of type load balancer from the yellow namespace. But in the gateway, we just use the same labels. So let's apply that as well. Gateway, yes, no, thank you. It's a bit lagging, sorry. Yellow, applied. So if we now do a kubectl describe services for all namespaces, get services for all namespaces, we can now see 3 load balancers being created automatically for each gateway 1, each with a unique IP from each unique IP address pool based on the labels or the namespace where they are created. And on the router side, we can see also these prefixes being advertised, and the BGP table being updated. So now the network knows automatically where to forward that traffic to for that specific services of type load balancer for the gateways you configured. This concludes the demo, basically showing usage of Cilium BGP, load balancing, IP pool addressing for multi-tenant, multi-IP address allocation. And with that, I'm also close to finishing the slides. If you want to try this yourself, I highly recommend our labs. We have an awesome labs on our isovalent.com website, also with BGP, also with Gateway API. Have a look there, free to use. You just register, and then you can use our labs. And when you complete a lab, you also get badges you can show proudly on LinkedIn or to your colleagues to encourage them to try the labs themselves. Obviously, the community is there for you to help. We're there on Slack. We have the documentation related to these capabilities on our cilium.io website. If you're more interested in the underlying technology, eBPF, feel free to go and check out those resources as well. If you want to see a live demo of cluster mesh this afternoon on 3 o'clock at our booth, we have a demo as well about that. So with that, thank you for attending this session. I hope you enjoyed it. I'm happy to answer any questions.
Thank you for that. So any questions? Is it time for me to get some exercise? Yep, there we go. That was an easy one.
I saw you, sorry, that was a lot louder than expected. The peering relationships you establish, you use IP addresses for that. Do you support using FQDNs instead for the peering relationships?
No, IPv4 and IPv6 addresses today. Yeah.
Okay. But it's technically supported by BGP. I'm not hallucinating, right?
Sorry, it's technically?
It's technically supported by BGP to establish neighbor relationships using FQDNs, right?
Okay, I didn't know that actually. I can check that for you offline if we have that on the roadmap.
I think I've used it in the past with FRR, yeah.
Okay, cool.
Any other questions? No? Really?
Did it make sense?
It's
a lot of information.
Room full of eBPF experts, I assume.
Awesome.
Okay. Well, another round of applause.
Cheers. Thanks. Oh, wow.
Surprise, surprise.
Thank you.